All right, here we go. 3.2 part B. I'm going to take that same data set we did just the other day. Why? Because I just like candy so much. We got sugar, we got calories, right? What we're going to do is put this into our calculator or put it into um, the Statlet. Got to do one of those two things just to kind of make sure that we know what we're doing, right? Because I got to be able to look at it, look at the FODs, look at all that stuff. So all these other questions I don't really care about. I'm just stealing the worksheet to identify this data set. Okay, so let's put it into stat, edit, L1, L2. We got our sugar and our calories. Again, here's what we got going here. We have a scatter plot. And I'm just going to make it, right, again, a rough scatter plot so that we can kind of see what we are doing here. So the importance isn't as much of are we getting these perfectly on the line as we are getting the trends for these things. Okay, so here's my scatter plot. Remember form, very much linear. Outliers, yeah, possibly. That one right there seems like it could be an outlier, so we want to watch out for it. Direction is definitely positive. Strength, I'm going to say moderate, something along those lines. So what we can do next then is build our least squares regression line. Let's do that in our calculator. Go stat, calc, let's go len reg. I want the number 8 len reg, and I want it to show up with all my things. Now here's the deal, mine isn't really coming up, so I'm going to go catalog, so it's second to the 0 button, catalog, and you're going to scroll down, scroll until you find diagnostics on. And I'm going to do this, and then I'm going to redo stat calc number 8, and it's going to give me the r and the r squared value. So these are really, really good for me. So now I'm going to write this right out of my calculator. It goes y equals, right, now the A value is 300.04 plus 2.83x. Now we can label these things because we know our x is here and our y is here. I mean, we know that we were doing what, sugar versus calories over here, right? But that's the equation. But then it even gives me these numbers. These are awesome. R equals 0.618. R squared equals 0.38, right out of the calculator, right? And also the Statlet does this for you as well. Well, let's talk about this. We've talked generically about these things, but the R value, remember, tells you the strength. But you can only use this if the data set is linear. Is it? I don't know. Use your eyes and you tell me. But yes. This one looks linear, so this makes sense. And there's my moderate, right? It's real close to 0.5. 0.5 is right, the medium. So kind of in the middle. If it's close to 1, we would call it strong. If it's close to 0, we'd call it weak, right? So that's what that is right there. Now we got the r squared value. Here's what we're going to need to know about r squared value. So let's do a little definition. R squared value is the percent of variation that, well, actually, you know what? Let's do this. Percent of variation between the x value and y value that can be explained by the least squares regression line. All right, so let's do this. The percent or fraction of variation, that's a fancy way of saying spread between the x and y value that can be explained using this least squares regression line, using the straight line data. So let's put that into terms here. 38% of the spread, right? The spread between all of these, right? The spread is just all that, right? 38% of that spread can be explained using this equation here. Only 38% of that, of calories, is sugar versus calories in this data set here. So maybe there's something else, right? So there's other factors in there. In fact, we're saying there's over 60% of that kind of lineup and that spread is explained by other factors. So sugar is not a complete explanation for calories, right? It's just one of the explaining benefits, one of the explaining factors of calories. So only 38%. So here's what I want you to do. Know this this definition for R squared value, because you'll see it almost written like that in AP multiple choices, right? So we want to know that right there. Okay, so that's some of the stuff that we've done. Let's talk real quick about residuals, right? We talked residuals. So the residuals, here's how you find it. Residual is equal to actual Y value minus predicted Y value. So okay, so a residual. So let's look at this. Let's look at the residual for what do we like here? Let's do Skittles. I like Skittles. Right? So let's do residual for Skittles. So if we were going to take Skittles, we know that the X is equal to 87. Right? That's its sugar content. The Y is equal to 450. All right, let's do this. So residual for X equals 87, just so that we remind ourselves, is equal to 450 minus predicted. Well, we don't know the predicted right this minute, so let's plug it in up here. So let's take 87, let's plug it into this equation real quick. Let's get a predicted value for 87. So 300, let's try that again. Let me try my calculator. 300.04 plus 2.83 times 87. Looks like we get 546.25. So let's plug that in, 546.25. All right, let's keep going. So 450 minus that gives me negative 96.25. So residual. It is really telling you how far your prediction is from the actual value. Now, if it's negative, that means my prediction was an overestimate. I overestimated on my prediction. If it is positive, that means I underestimated. Right? Underestimated, because my estimate is below. So what is that? So let's take this number, negative 96.25. Let's go find 87 on this graph. Now I'm going to go back to my graph real quick. I'm going to trace. I'm going to find that one with the 87. So it is, in fact, this lowest one here. That one is the Skittles one. So if I had my least squares regression line, right, a least squares regression line is going to go through here somewhere. So what we're saying on this, my residual, the distance between the predicted and the actual happens to be 96.25. That's its distance. But now if it's below the line, then it's negative. Negative. Yeah. So there you go. That is a residual, right? A single residual. So you should just be able to calculate a single residual using this formula every single time. Now, a lot of times we have to do this for this prediction part of it, right? That's going to be on us, and then we can plug it all together and get that. Okay, so that's what you end up with on that one. So let's move on to now what happens if I found all these residuals, right? So that is just one of the residuals, but if I went and found all 12 residuals, right? And then I can create a thing called a residual plot. Now we won't create these very often, but this is called a residual plot. So a residual plot, these over here are the residuals, right? So then these are my negative residuals and these are my positive residuals. And so what we do, we come place all of these on here. These would be the x values, right, that we're using. So let's say 87, x value was right here along the 0 line. It's got a residual of negative 96.25. So once we got that on there, now we'd go back and we'd find all of them in there. But um, but we're not really necessarily going to do that right now. I want to like explain the residual plot, so I put all 12 of them on there. So I'm going to put these in blue so that it makes a little bit of a difference here. But what if I started doing residuals and they ended up all over the place, right, like this? And so what we're going to do with this is assess linearity, okay? So using residual plot to assess how good of a linear fit my data set is. So here's what we're looking for, right? For linear fit, a good linear fit, we need no pattern in the residual plot. And number two, we want it to be roughly equal spread. Okay, so those are the two things. But the most important is no pattern in the residual plot. So let me give you some bad ones here. 0, and then if I started plotting, plot, 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 all the residuals. Whoa, well that's looking like a pattern. So is this a good linear fit? No. Well, let's try let's try another one. Let's try what about one that was like this? And I started plotting residuals and they look like this and like this. Okay, so points below, points above. So this one, the bad thing, it has no pattern, so that sounds good. But see how we're barely above here and we're way below here. That's not equally spread. So let's say no. No to this one. Okay? So that's a no. And then we come over here to another one. Let's say we had one that was like this, right? So it's kind of here, and then it gets bigger, and then it gets bigger, and then bigger, and bigger, and bigger, and bigger, and bigger, and bigger, and bigger. Again, no pattern. Well, I guess you can kind of say that as a pattern. I kind of feel I know what is happening here. It's getting wider and wider, but that's not also not equal variance through there. So let's call that a no. So what do we need? No pattern and roughly equal spread all the way through this thing. Roughly equal. It's not going to be perfect. It is stats, right? We have to always deal with that. So that's what we're looking for a residual plot. It will help us to assess how good of a linear fit my data set is, right? So no pattern and roughly equal, that means it was linear, right? Because sometimes our eyes deceive us, right? My first job is always to see, is this data set linear? If it looks good and linear, usually we go with it. But what happens if I can't really tell? It kind of maybe looks linear, but there could be some outliers. I don't really know. Well, guess what? We will go to the residual plot every time to assess it and see is there no pattern and does it have a roughly equal spread on that thing, right? So that's what we will be looking for. All right, one more piece to kind of think about here is let's say I have my data set. Remember, it's all those blue points in there. So getting a little rougher. I got all kinds of stuff happening here, but all these blue points are those. So there are things called influential points and outliers. So what we need to know is just like what happens when we put those in there. So let's say I'm going to use yellow to say. Let's say I found a new candy bar, had sugars, high sugar content, but a low calorie count, and I put it in the data set. All right. What happens to that least squares regression line? That least squares regression line has to take a little bit of a bend, right? Because it's trying to go right in the middle of all this data, so it's doing the best that it can. This new new point over here came in. And so now, unfortunately, what that's probably going to do, it's going to influence this line to kind of take a little bit of a nosedive because it's trying to suck closer to that, but also kind of keep this going right here, right? So with that, what happened? My y-intercept just increased, and my slope, my overall slope, decreased. So think about if I put new points and they weren't perfectly aligned with the other points, what would it do to all of my, what would it do to the data points? So nothing, but what would it do to the least squares regression line, right? That's what we need to know. So that's what we'd have to look for. So anytime that we have a point outside, right, we call them outliers. And then sometimes we have ones that are called influential points. And outliers really lie above or below the line and aren't really going to shift it too much. But influential points, man, those are ones like this that are really going to make that least squares regression line shift quite a bit. So that would be my influential points there. All right, so that is kind of a lot to go on there, and then we need to do one last thing. I want you to be able to read this thing called Minitab printout. Minitab printouts look like this right here. Now this one has a lot of stuff on it for us. Usually we don't get all that stuff. A lot of times we don't get this right here, and this is all we get right here. So here's what I want you to look for Minitab printouts, because this is great. This is like it just came right off of a computer set. And then so we get a chance to have to use it. So what I'm going to do with that is just talk about what are the big important things that I need to know in order to use this Minitab printout, right? Because that's the important piece to us. So on this, there's a lot more stuff than we actually need on this stuff, but here's what I want you to find. I want you to find the word constant. Yep, that word constant. The word income. And notice I'm just highlighting the coefficient part. The S value and the R squared value. Everything else for now, which would be all this stuff here, 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 anything else that comes up on these graphs, I want you to ignore them. For now, we'll use them later. I want you to ignore them. So I'm looking for the word constant. I'm looking for another word that is called a descriptive word. I'm looking for the S value. I'm looking for the R squared value. So all those things can give me what I need. All right, so when I'm thinking about least squares regression line, y hat equals a plus bx. Here's some things that you can figure out in here. The descriptive word, not the word constant. The word constant, it will usually always be constant, but the descriptive word income, that is your x value. That's what this thing is. So I can say, it's going to be y hat equals a plus b times income. So it's telling you what the x value is, income. If you get a chance to, usually we'll find something like up here in the title, it says cost versus income. So then I know that I could actually write this in. Predicted cost equals A plus B income. Like this, all right? Okay, so the next thing that you're gonna look for is the word constant. Did you find the word constant? Go find its coefficient, constant coefficient. So this is 438.525. That is going to be your A value, 438.525. That's my constant. Okay? And then you're going to go find the descriptive word, right? Find the descriptive word. And what we're going to do with that one right there is find its coefficient, and that is your slope. Slope, right? So that is going to be 0.51145. Okay? Everything else is good. Income. And we got cost. Predicted. Put the little hat on it. I just found the least squares regression line from this output right here. Man, that's all you need right there. See, that's why computers are so good. It's already doing all the work for me I don't need to have to always do the work if it's already going to be done in a computer. My job is to assess what is going on in that computer. There it is. Now I can make predictions, things like that. Now here's the R squared value. That's the percent of variation that's explained using this. Wow, 91% of the variation between cost and income can be used explaining this. Well, that's good. That's good because that's a lot. So it makes me pretty confident that cost and income are very, very well linked on this. All right, so that's that. So one other thing that's on here then is S value. The S value, when you're looking at one of these graphs, that is the standard deviation of the least squares regression line. Standard deviation of the least squares regression line. So you're like, so what? Well, the least squares regression line, standard deviation, it's based on residuals. Okay, so what were residuals? Remember? Residuals, where are they? Residuals are how far you are from the line. So if they're based on residuals, a standard deviation is the average distance from something. So it's the average distance from the line. So this number, the S value tells you if you make a prediction, and that's, using this equation, if we make a prediction, then this is how far off our prediction is expected to be. Okay, so it's a standard deviation calculation. If we make a prediction, we can expect, here it is, 12.25. If I make a prediction, I give you an income and you give me a predicted cost, I can expect that cost to be off by $12.22. Right? That's the expectation. Does it mean it's going to happen? No. That's expected though. So we just want to take that into account. So if we have a really, really high R squared value and a really, really low S value, then I look at this equation, I say, wow, I like that. It's going to make me good predictions. And this is business, right? Sometimes, or this is what we use in business. So to make good predictions, we want small S values, right? Tell me that when I make predictions, it's not going to be off by too much. And I want high R squared values that tell me that these two variables are very, very strongly linked together, right? So that's what that's going to tell me. All right, so that's what we have here. So this is all stuff right here that we're just saying, there's a lot of correlation and there's a relationship here, and we're trying to define it by finding equations, plotting them, talking about FODs, doing predictions, finding things in the least squares regression line, right? Doing all that stuff. All right.